So in our last video, we learned how to use this Valtrack V4 to track our real-time location with the help of its built-in firmware and the Valetron's own mobile application. And in that same video, I told you that this board is completely programmable as well. So now in this video, I'll let you know how to program this Valtrack V4 using Arduino IDE. I'll let you know how to provide some AT commands to that sim module to do all the tasks. And in the end, I'll be making a complete code to send my real-time location to Adafruit IO dashboard using the MQTT protocol, and I'll be sharing all those code files with you so that you can try the same project on your end as well. So this video is for all those DIY enthusiasts and hobbyists watching my videos. So let's just not waste any more time and let's get straight into it. But wait, let me thank my sponsors first.
This video is sponsored by LTM, which is a PCB designer based software company. Now LTM is not just another PCB designing software, rather it's a world-class and award-winning PCB designing tool that has some features like advanced interactive routing with auto-completion, any angle routing, bus routing, phase and length tuning, follow me more, and much more, which makes it an ideal choice for PCB designing by a lot of companies. Along with this, they do also have LTM 365 that not just covers the PCB designing part but also helps with design sharing via web, sharing designs to mechanical team for product design, centralized cloud storage, and a lot more. And along with all this, they do have a very useful search engine made just for electronic components called as Octopart. Using Octopart, you can search for any components and you will be able to compare its price and availability around the globe. Not only that, you can also get the details about the components like its specifications and datasheet all at one single place. So LTM provides everything to make your production task a lot easier. So do try out all these services right now, as you'll be getting a free trial version by just clicking the link mentioned in the description. Happy making!
So now to upload the code into the Valtrack V4, we'll first of all open up the Arduino IDE. So currently I'm using the version 1.8.19, and the one thing which you need to be sure about is your board's package of ESP32 board should be updated to the latest version. So if I let you know the version which I'm using, then here I'll type out ESP32, and currently I'm using the latest version which is 2.0.12. okay, so make sure you have this version or higher version than this. Click on the close button, and after you update this board's package, one new board will appear into the ESP32 boards section, which is Valtrack V4 VTS ESP32C3. So this is the board which we need to select to upload the code onto the Valtrack V4. So I'll select this board, and now talking about the code part, then here Valtrack company has already provided one sample code with all the initializations and everything on their official website. So I'll let you know where is that code. So yeah, here is that particular code. So I'll simply copy this code and I'll paste it here inside my Arduino IDE. Now here all the pinouts are defined here, like the UART pin for sim module, for like motion sensors, and every pins are defined here. So you can check that out here. And till the setup part, they did all the initialization. So what I'll do is I'll keep the setup part as it is, and for the loop part I will remove all these things because they are performing a particular task for connecting to a particular server and stuff like that. But what we need is we need to use this board, this Valtrack V4, using our own AT commands, and for that I removed this loop part, and in this loop part I'll add this much line of code. So this code was copied from the multi-serial example code in Arduino IDE. So this will help us to send the AT command and see its response onto our serial monitor. Okay, so this is the code. Well, I'll be providing this example code in my GitHub repository, whose link is down in the description. Okay, so I'll keep this code as it is, and now I'll select the right board which was already selected, Valtrack V4, and I'll select the right COM port which is showing here as ESP32S3. But yeah, this is the board, this is the C3 board. I'll select this and I'll straight away hit the upload button. Now let's just wait till the code get uploaded. Okay, so the code is successfully uploaded. I'll open the serial monitor, and okay, we are getting the response onto the serial monitor. So let's just wait for all the setup part to be executed by this code. Okay, so the setup process is now completed. So I'll type AT here, and as you can see, I got the response as okay. So we are successfully able to communicate with our sim module using the AT commands. Let's just try out a couple of more AT commands. So I'll type at AT plus COPS is equal to question mark, which will let us know the available networks. Okay, so we got the network. So it says VI India. So here I have attached the VI SIM card, and so it is getting the network from VI India. And if I check out the signal strength by typing the command as AT plus CSQ question mark, Okay, it is 80 plus CSQ only. Okay, so we are getting the received signal strength indicator as well. So the SIM card is properly working, it is properly connected with the cellular network, and the AT commands are also working. Now let us move ahead and see how to get the GPS location using the AT command. So for that, the first command which you need to enter is CGNSS PWR. So when I press question mark, as you can see, it is written as 0,0,1. Now we need to make it to 1,1,1. So I'll type as 80 plus CGNSS PWR is equal to 1,1. Press enter. It says okay, but still we need to wait till the response CGNS power ready. Let's just wait for that command. Okay, so we got the CGNS power ready. So initially I was not getting, so I resetted this using the command AT plus RESCT. Then again I provided this command, and now I got CGNS power ready. Now this is a very important step. So until unless you don't get the CGNS power ready, you won't be able to do all the GPS related tasks. Okay, so once we got that, now we are good to go to type one command to get the location. So I'll type AT plus CGPS info, okay, and I press enter. As you can see, I'm getting the latitude and the longitude data here. Okay, so that's how you can get the location coordinates using these two AT commands. Okay, so now I don't need to do the CGNS power once again. I can type CGPS info, and I will be getting the real-time coordinates. Now these coordinates are of course not in the proper format to be sent to a cloud server. So we need to do two steps now. We need to convert this format to another format which is supported by the cloud server. And secondly, we need to embed the code about like MQTT based code to send our data to Adafruit IO server. So first of all, let me show you how to set up the Adafruit IO account, and then we'll move on to the code part. Okay, so first of all, you need to make the Adafruit IO account. I'll leave its link down in the description. So it's an MQTT cloud broker. Okay, so I already made my account, and after making your account, you go to feeds. After that, click on new feed and type as GPS LOC, which stands for GPS location. Click on the create button, and we successfully created a feed. After that, you need to go to the dashboard. Click on the dashboard name, which in my case is the welcome dashboard. And here I'll click on create new block. And here I will be adding the map widget and select the GPS LOC as the feed name. Okay, block title will be map, and click on the create block. Okay, so this is the map. Now here we can edit the map lookout. So I'll click on edit layout, click on the edit button here, edit block, click on next, and here let's just select the straight map, and here also straight map. Okay, click on update block, and as you can see, we got a straight map view. Okay, so I can click on the save layout button, and I can zoom it in, and I can see the location. So with this, we have successfully created the feed and the location widget on our Adafruit IO dashboard. And that was it about the Adafruit IO configuration. Now let's move on to the code part. Okay, so here is the code I wrote for sending the location data to our Adafruit IO broker. Now there are a couple of changes in this code, so let's just try to understand this code carefully. So first of all the necessary configurations for configuring our Valtrack V4 device, which I taken from the example code itself. Now here the APN name is written as www because I'm using the VI SIM card whose APN name is www. You can search for the APN name of your network provider on Google and provide it here. After that, here you need to write as io.adafruit.com. So in case you are using the same broker, the address will be the same. Now here we need to provide the topic name, which in my case is Sachin_SMS/feeds /GPS LOC /CSV. Now here Sachin_SMS is nothing but the username of my account, which you can get it by clicking on this key icon, and here is your username. So you just need to replace this with your username. Then /feeds will be the same. Then here is the name of the feed, which we have set to GPS LOC, and /CSV. Now here we need to provide as /CSV whenever we need to use the map widget. So this is a mandatory condition. So this is the topic GPS. After that, again the necessary configurations, the setting up of this Valtrack V4 device. So I just skip everything and let's just jump directly to MQTT connect function. Here you need to do some changes according to your account. So in this, here you need to provide the username, and here you need to provide the AIO key, which you can get it from here itself. Okay, so this is the username, this is the AIO key, and you need to provide those credentials here to make it work in your account. Okay, so that's the mandatory change. Then the setup part is same as before, which we have tested in the example code of this. And here what we are doing is, along with all this basic commands, we are also providing CGNS power is equal to 1,1. Now I already told you before that we need to provide this command whenever we need to use the GPS related or location related AT commands. Okay, so once we get the confirmation like CGNS power ready, then we are good to go for the locations. Okay, so we are waiting for the response from the Valtrack V4, and as soon as we get the response, we are good to go to get the location. So here we have made the function called as get location, which is passing on the command cgps info, which will give us the response. Okay, so after giving us the command, we'll be waiting for the response, and here is the tricky part. So the response which we are getting is in the format called as ddmm.mmmmm. Now, in case if you don't know what is this dd and mm, let me make you familiar about all these things. So GPS coordinates are given in way different formats. So the format which is given through this Valtrack V4 is in this format called as ddmm.mmm. This is the decimal minutes format. So this is the format which we are getting from the SIM module, but the Google Maps API or the Adafruit map widget doesn't accept this format. Rather, it wants the format of decimal degrees, which is here. Okay, so we want this particular format of location. So we need to convert those minutes into decimal degrees, and it has couple of formula, like we need to split the data, divide it by 60s and stuff like that. Okay, so all those division and splitting and combining all these things is done here. So we are converting the longitude value here, and we are converting the latitude value here. Okay, like the format conversion is happening here, and after we convert the format, we are creating a string which is containing the data of speed, latitude, longitude, altitude. Now this format is accepted by the Adafruit map widget, so we need to provide the data in this format only. Now here in our case, speed and altitude value is not provided from this board, so we are providing the value as by default 0. Okay, and after that, in between, we are providing the latitude on the longitude value, which are converted by these all formulas, and finally we are sending, like publishing that data to the topic GPS. Okay, this whole coordinates are saved in the character pointer called temp. In the end, we are publishing that data, and this data is published after every 10 seconds. So after every 10 seconds, we'll be getting a new location data on our map widget, like on our very own cloud, without using the Valtrack's own mobile application, without paying to their services. Okay, so that's the basic code. Okay, and here also we are using the MQTT connect function to establish the communication with the MQTT cloud, which is called inside the main loop only. Let me show you. Okay, so here is the MQTT send data, which is responsible for establishing the communication with the Adafruit MQTT broker. So that was all about the coding part of this whole our own tracker. Okay, so what I'll do now is I'll select the right board, which is hopefully selected, and right COM port is also selected. I'll straight away hit the upload button. Now currently I have placed the tracker outside the window so that it can get the GPS coordinates. As we know, GPS doesn't work indoor. Okay, so let's just wait for the code to get uploaded. Okay, it's done uploading. I'll open the serial monitor and let's observe what data we are getting here. So here is the data, location data coming from the SIM module, and after that we are converting it to our required format. So here is the longitude and here is the latitude, which we are ultimately sending it to the Adafruit IO server, and its status is published. Okay, so it is publishing the data. Now let's just move on to the Adafruit IO server and let's just observe if we are getting the data or not. Okay, so we got a dot here. Okay, so that means it is tracking a location. So my device was turned on for quite a couple of time ago. So it is constantly sending the data. It is making the track of the different dots. Okay, so basically here is the techiesms studio, and I am getting the data from this module, which is sent to my Adafruit IO server. And now let me just fix this device, like pack with the battery, and let's just take it on a long ride and test it with our own Adafruit IO dashboard. So that was the second part of this Valtrack V4, where we tried to program this board to send its real-time location to a third-party platform. In our case was Adafruit IO, and similarly you can use this technique and use that code to transfer the location to maybe your own cloud as well, in case you have. Well, I'll be providing this MQTT based example code for this device down in the description of this video, so do check them out. And also we are selling this Valtrack V4 hardware through our website with both the options, like with casing and with without casing. Again, its link is down in the description of this video, so do check them out. And yeah, that was it about this video. Do hit the like button if you really like the product, and also share your thoughts regarding this product or this video down in the comments of the video. Like, will you be going for this product, or rather you'll be preferring making your own GPS based project? Well, share your thoughts down in the comments of the video, and we are definitely coming up with a more GPS tracker based DIY project that is coming soon on our channel. So make sure to subscribe to the channel to see something new in the field of GPS trackers. And yeah, that being said, I am just ending this video here and now. Just wait for my next video. Until then, explore, learn, share with me, techiesms.